what we're going to talk about is critical time delay measurements. When we're talking about critical time delay measurements, first thing that comes to mind is who this is important to. And we have noticed that ANSPs, so service providers, are very interested in this area of our test solutions. And they need to know basically the manufacturer's equipment that they're purchasing and that they're thinking about purchasing for their deployments. Are they performing well, from a delay perspective? So these products that I'm going to show you in the next few slides can actually help verify that. So delay from point A to point B within the network. You can surround different products, different nodes in the network, and make sure that the delay through the product is meeting a specification that you may have as an ANSP. So that's one area that we found a lot of interest with these time delay measurements. The other area is obviously within the equipment manufacturer, so VCS guys and creating CWPs and making sure that their processing within their CWPs is adequate from a time perspective, as well as radio people. So we've noticed that this is catching, it's getting good reviews in the market because it's very precise and it can do a repeatable test to verify delay within the network. So I'll just start out by showing a very simple diagram here of a ATM network. On the left-hand side, you'll see that a legacy VCS is being represented. You have a controller represented on the far left. The legacy VCS will connect via to the network via a VoIP gateway, and then now we've got ED137 presumably in this arena. Now on the far right, or this portion of the network, on the far right we have a VoIP VCS. So direct ED137 to the VCS and then an additional CWP. So we're showing a legacy deployment with a VoIP interface, a VoIP gateway interface, and then a purely ED137 VoIP VCS deployment. On the top side of the diagram, we're showing a ground radio station. Now, we did not break it out, but you can also imagine that one option would be a pure ED137 directly into the radio, pure VoIP directly into the radio, or via a gateway. Okay, we'll call it. So sort of a legacy from the gateway downstream to the radio. Now, where the timing measurements become important are throughout the network, of course. And what GL has done is brought over some products that we've had for years in telecom testing to put into this ATM world where we can measure delay. So you may want to measure delay in two different areas. That's kind of how we break it out, sort of in the analog world and in the IP world. So different points within your network become important there. So at this point, we're talking purely analog. Even here, it's an analog connection to some extent. After it goes through the gateway, it's an IP connection. So now we're talking Ethernet IP with ED137. All of this is being represented by IP as well. But after the VoIP VCS, it obviously will go back before the controller hears it to an analog world. So we've got products that can sit now at different locations here. These two products mainly focus around two products. One of them is called the audio analyzer. So the audio analyzer is a product that can interface in the analog world, as you can see. And then we've got another product called a packet analyzer, which is able to monitor in the IP world, in the Ethernet world. And we'll show you a little bit more about each one of those at a high level. But both of these products are sort of the building blocks to allowing us to do measurements from T0 over to T2, from T0 to T3, wherever you want to go to and from, we're able to do that. And we can show you. So you can isolate, for instance, in this situation, you can isolate from T3 to T4. You can isolate the VoIP VCS to see the processing time that it takes for for instance, let's say a PTT to be enabled on the analog side to when the PTT bit in the ED137 protocol is enabled. So that can be timed very precisely, very repeatably with our product. So you could do that 100 times, 1,000 times, just to see how this VoIP VCS is performing. Okay, and you can get the picture on how you can do that from different points within this network. So I will tell you this as we move forward here a little bit. I'm going to one slide will be devoted to the audio analyzer, which will be first, and then I'll devote another slide or two to the packet analyzer. The event data logger, we're showing it here, the guy that we use to pull in all of these times and to a common platform, and then that's sort of the timer in a sense. So it has the master clock for all of this. We'll show you that. So the audio analyzer. This audio analyzer, again, in the analog world, can emulate a controller. So it has the ability through this interface right here to connect to your, what we call a dual jack module on a CWP, and it can, through software, can enable and disable PTT at the CWP, and it can send and receive audio. So it's emulating a controller in a sense, in an automated fashion. So through software, and this hardware can emulate a controller. When those events happen, so when PTT is enabled, when PTT is disabled, when audio is being sent, when audio has been detected, we can send a TTL trigger out to an oscilloscope, maybe in a lab where you want to see what time that actually happened, or to that event data logger that we're showing in the previous slide, where we can time it and do a time delta between maybe this interface and an IP interface. So that's what this product does. It interfaces again at the analog side, so it will emulate a CWP, and it can inject and record analog signals at that CWP. It also, in an ancillary fashion, has the ability to send and record voice, of course, as I mentioned, and it can perform voice quality measurements. So you can send from one point in the network to the far CWP and test the voice quality across the entire network. It's been set up as well to play very nicely in an automation environment. So you can talk to this thing through a CLI or an API, and you can integrate it in with third-party test tools. We've actually done that to some extent with the event data logger, because we're talking to all of these guys and at some interface getting the time. Okay. So what I'll say about the packet analyzer, okay, now this is the product, this is the hardware product that is interfacing at the IP interface. So it's basically taking packets in and passing them through the device, through these things we call the span ports. So it's passing audio and IP packets in one port and out the other. I have a demo of that here just in the next slide, which will show it a little bit better. But as those packets flow through the device, it has a filter, and a filter can be defined to pick off a packet of interest. So when I mentioned earlier about the PTT bit in the RTP packet going high and high or low, we can be looking for those things as the RTP packets flow through. And when they happen, we have the ability to time it. So you can see that these very precise events in the RTP and the IP world can be looked for through our filter mechanism and then triggered. And again, the time is the critical thing there, and we have that. So we can filter at layer 2, layer 3, and layer 4. Again, automation is been built into this product through a CLI and an API. Okay, so we have that. What I'll show you here is how that packet analyzer works from the filter perspective. It's a very simple demo with some automation, but it shows that as packets flow through the device, okay, we use port 2 and port 3 as sort of what we call our span ports. So as network A is pushing packets over to network B, we're running it through our device. And as those packets flow through, we've got our filter defined, okay? And when that filter sees something of interest that you have defined, again in the example I mentioned where the PTT bit goes high, we can push those packets on over and then downstream to our timer, okay, our event data logger. And so there's a built-in filtering mechanism here, and that's how we're doing things. We're passing all traffic through our span ports, and we're filtering out our packets of interest, whatever may be defined there, and whatever the test calls for. And we're sending those out to our event data logger where the timing is being tagged. And again, that's where the timing is, and that's where you can delta the times within your network. So to summarize that, going back to this diagram, from different points within your network via analog interface at a CWP, we can get a very precise time of when events happen. So as mentioned, these events can be defined by the user. Audio coming on and off when a controller maybe mutes the when he mutes the CWP, he or she mutes the CWP, we can be timing that type of thing. When the audio starts and stops, when you mute and unmute, we can look for those types of things. We can look for different events throughout this network. There's many to choose from, and we can do that. So that's the summary of how we're doing our critical time delay measurements.